from IIT Madras, and today we are with our new topic, that is Pascal's law of fluids. What do you mean by Pascal's law of fluids? What actually Pascal's law of fluid states? What Pascal's law of fluid states? So we are going to study about the Pascal's law of fluids. One scientist named Pascal, he had stated a principle. Let us take a container for better understanding. A container filled with a fluid or liquid. A container filled with a liquid. Consider some liquid. For example, water. Some pressure is applied from this point. Above point. What Pascal has actually stated, it was that when any pressure is exerted to a point, in any liquid column, the pressure is exerted in any liquid column, this pressure is distributed uniformly at all our points. Pressure at this point will be equal to pressure at this point. Any point in a liquid, the pressure will be constant. Pascal's law states that at every point in a fluid, a fluid immersed within a container, remains the constant. Pressure always remains the constant. What Pascal had stated, pressure always remains a constant quantity. Pressure is always a constant quantity. It is distributed uniformly. Pressure is distributed uniformly. Pressure is distributed uniformly at every point. Pressure is distributed uniformly at every point. Which law states this? Pascal's law of fluids. Pascal's law of fluids. Pascal's law of fluid states that pressure at every point, is distributed uniformly, and hence it is the constant quantity. Pressure always remains the constant quantity in terms of a fluid. So this law is having many of the applications. One is the hydraulic lift. Second is the aircraft, how an aircraft lift off or take off. Third one is the hydraulic brakes. And the fourth one is the venturimeter. 4 applications of this law. Pressure at this point, say this is the height h. This is the height h, and this is the height h dash. So pressure is independent of the height here. Pressure at this point will be equal to the pressure at this point. So P initial is equal to P final. P is equal to P dash. When the pressure is constant, P initial is equal to P final. Next we are having the applications of the Pascal's law. The first application of Pascal's law is hydraulic lift. How an hydraulic lift works. Consider a hydraulic machine. This side is the larger area. And this side the smaller area. This is the smaller area of an hydraulic machine, and this is the larger area of the hydraulic machine. So what we are having here is the pressure. Some pressure is applied from this smaller point. Say here some pressure is applied. It is small p. It is denoted by small p. And some force is applied, small f, on this particular area, small a. This area is small a. The area of this point is capital A, and the pressure is capital P. Some force capital F is experienced here. So what, according to the Pascal's law, a hydraulic lift is a device which lifts off a vehicle. Some vehicle is kept here. Suppose a jeep or a car, some vehicle is kept here. So this vehicle is lifted over. Okay, this vehicle is lifted over by this pressure. Okay, when we are applying through the pressure some small amount of area. Okay, pressure at this point will be equal to pressure at this point. Small p will be also always equals to the capital P, or P is always equals to the P dash. P is always equals to the P dash. According to the Pascal's law, P is equal to P dash. Capital F by A, that means capital F by A must be equal to small f by A. Small f by A. This is the numerical expression for hydraulic lift. Hydraulic lift is the application of Pascal's law. This is one of the application of Pascal's law, hydraulic lift. So when we are provided with three parameters, for example the larger side area, small area, and the small force, small amount of force. So how we can find this the larger amount of force? Capital F is nothing but F by A times the larger type of area. This will be the final expression for this one. So these are the expression for hydraulic lift. Hydraulic lift is an example of Pascal's law. Okay, it is an application of Pascal's law. Okay, pressure at this point will be equal to pressure at this point. Okay, these and that both points are getting same amount of pressure. Okay, so both pressures are equal. That means capital F by A is equal to small f by A. Or we can find the value of capital F by transferring this quantity to this side. Okay, LHS from LHS to RHS. We are shifting one parameter from LHS to RHS. Thank you.